Okay, so we need to finish off 3.
Was there a problem with 3? I think there
Yeah,
was.
we need to finish it off.
Yep.
All right.
Oh, shit.
So let me just quickly double check what was the original question of 3.
Oh yes, we don't know our initial volume. I wrote this down here. We don't know our initial volume.
We don't know the initial volume. Fun times.
It's concentration. We don't have our initial volume, concentration of our amounts, or our amounts. Sorry.
Cool. My thing isn't loading for some reason, which is a bit disappointing.
Yeah, you're missing some of that. Like those are just the like what Mrs. put there isn't all of the question.
Yeah, that's the thing. That's why I want to quickly.
Oh, do you have the?
Yep, found it. All good. Found it. All good. Perfect. Okay, so we've done 1, 2. Let's just do 3. So you've got the question. A sample of bore water from a mine contains equal amounts in mole of dissolved, not dissociated. I need to learn how to read. Dissolved silver carbonate, which, let me get my pen out again, is this one right here. That's silver carbonate. And it's dissolved in silver carbonate, and you've got iron carbonate as well, which is this one right here. You've been given the KSP values, which I can see on the screen, which was good. And using this data, determine in order in which the ionic solid will precipitate if the water is allowed to evaporate. Okay. So
that's right, because we don't.
Pardon me?
Your mic sounds really bad. For 1 second.
Can you hear me now?
Yeah.
You can? Alright, I'm just going to stand up because I've been for a long time. Alright, so let's do this step by step. Hello?
Yeah.
Yep, you can hear me? Cool, because you just froze for a second. Okay, so let's do this step by step. The first thing we're going to worry about is writing down our equations for both sodium carbonate and iron carbonate.
Okay.
Yep. So don't look at your sheet of answers. Let's do this. Let's work hard for our answer.
Okay.
Okay.
So we have Ag2CO3. And it's disassociating.
So yep. So you're gonna have your equilibrium sign. Remember, it's not gonna be a straight arrow. It's gonna be an equilibrium arrow.
Yep.
Perfect.
And that's going to our. So we're gonna have
aqueous plus.
Yep.
Carbonate. So CO3.
Yep. Ag. Why is it 2 Ag? Why have they put 2 Ag? Is it because it's 2? Because it's 2 minus and that's plus. All right, makes sense. Okay, I get it.
So right here, can you see that in our product, which is we've got 2 Ag right here. Can you see?
Yep.
So it's pretty much balancing the equation. Does that make sense?
Yep.
Yeah. So we're putting 2 Ag. Remember, plus its charge is 1 plus, and then with the carbonate, its charge is 2 minus.
Yep.
Perfect. All right. So first thing we've done is we've worked out our equation. It's balanced. You've got your states, which is aqueous, and you balanced it. Now, we need to find S. So solubility, how much has dissolved? That's the point of the question. So what we're going to do is we're going to do, as we did above, we're going to do KSP equals to Ag, so our products, which is Ag to CO3. Does that make any sense?
Ag and then CO3. Okay.
Yep. So remember, as I said, same situation with the fluoride right here. If you've got a number in front, you have to put it up as a power and you have to square it. So it's going to be Ag squared. Does that make sense? Because we had 2 Ag in the equation.
Yep.
Perfect.
So, so then I might just write this down.
Sure, you definitely.
And you put the squared there, of course.
For the
And then
silver, yes, because we had 2 Ag in the balanced equation.
what's above? Why is it? What's above the CO3? Is that 2 as well?
2 minus. That's its charge. Don't worry about that.
All right, of course.
Remember, it's inside the bracket. That means is its charge. Outside
yes.
the bracket means is what you're timesing it by its power. Does that make sense?
Yep.
Perfect.
Yep.
So what we're going to do, remember like last time, we've got KSP equals to our product. Yes? Do you still agree with me?
Yeah.
Perfecto.
Yeah.
So what we're going to do is we're going to do your KSP, which is your value that's given on your worksheet, which is, as you can see here, 8.1 times 10 to the negative 12 is going to equal, remember we're going to do it as 2s squared times s. Now I'm going to explain it to you. Yeah. So
because there's 2 of that.
Yeah. So remember there's 2 Ag in the equation. If you follow my cursor right here, we've got 2 Ag, right?
Yeah.
The Ag is equal to 2s. And then the CO3 2 minus is just an s because there's no number in front of it.
Yep.
Perfect. Does that make sense?
Plus s. Yep. So that it's just because there's just one s, but that equates. All right. Okay.
Yep.
And then you add those together, and you get 3s.
What you're gonna get, not add. Remember, it's times.
Yeah.
So you're gonna get your case. What's your case P? It's 8.1 times 10 to the negative 12. Is that correct?
Yeah.
Perfect. And it's gonna equal. It's gonna equal 4s cubed. Do you know how we got 4s cubed?
Times 10 to the negative 12. And then it equals to s3.
Yeah. So we did. Can you see here? We did two. We had 2s squared, and we just times in that s.
Yeah. And then you get another s. So then
Yeah. So you get 4s cubed. Does that make sense?
4s cubed. Yes.
Perfect.
Why?
So what you're gonna do now?
Why is it on the working out that I'm looking at from Miss? Why does it say 3s3?
Yeah, we'll get there. Just wait. Patience. Patience, grasshopper. So next thing we're gonna do is we're gonna divide this by 4 and this by 4.
Oh, so that's why it's 2.02. Okay,
Yeah, correct. So divide both sides by 4.
Which then gives us that. So then
Which
it gives
then, okay, time to rub out because I don't have space anymore.
Times 10 to the negative.
So then
12.
you're going to be left with, as you asked me, why do you have, you're going to left be with s cubed.
She missed out that step.
Well, which is not good because then you don't know what the hell you're doing.
She didn't tell us that, yeah, divide. She should have probably left that for us because we're the ones supposed to be figuring it out from hers. Okay,
Yep.
whatever.
Yep, so you're going to get this. Does this make sense? We're right here right now.
And then
So
S.
You need to make s the subject of the formula, so you're going to cube root both sides.
Yeah.
Make sense?
Cube root 9 times 10 to the negative 12 and cube root. Yep, that's fine.
Wait, what? What did you get 9 times? What?
No, cube root 2.0.
2 times 10 to the negative 12. Yeah, perfect.
Yeah.
Which will give you the answer of 1.26 times 10 to the negative 4. Does that make sense? Is that clear?
Yes, that is.
All right.